Good evening. Um, this, my presentation topic is magnetic field assisted freezing. And paper's title is on innovation of magnetic field assisted freezing of the perishable fruits and vegetables, a review. And our presentation focused the magnetic field assisted freezing, the function, introduce. This figure is a water molecule arrangement in fruits and vegetables. And we can look at free water and bond the water. And the water content is a content of the bond water tied up to protein or other molecules, and free water without being tied with available for freezing. This page is the definition of the freezing. Freezing is defined as processing which temperature of the product is lowered to minus 18 Celsius points or below. By cooling below freezing temperature, energy is removed. The physical state of the food food product is altered. Freezing process is completed in the three steps: cooling, freezing, and future cooling. As the cooling step is first step is cooling step. Food is brought in contact with the freezing media, during which sensible heat is removed to lower the temperature up to freezing point of food. It is important at the point that water remain in the liquid state, and the phenomenon is called supercooling. That is the state in which temperature of food product drop below the freezing point without the formation of ice crystal, thereby result in yielding better product quality. And the second and third freezing step and future cooling. And show this graph, and we can see is a huge temperature rise. It means the water molecule is changed ice. Ice crystallization ice crystallization consisted of the 죄송합니다.
나중에 말씀해도 돼요.
일단 준비 와서 계속 해보겠습니다. And the crystal grow. More is the degree of the supercooling, more amount of ice is formed at new creation. Later, heat is removed as the latent heat and temperature declines, and heat and the temperature declines, and the product temperature remains stable. After that, product temperature is lowered to equilibrium, and the most sensible heat is removed. And this is the effectiveness of freezing. Effectiveness of freezing depends on size, shape, and distribution of ice crystal from the during freezing, which future depend on freezing kinetics, rate of ice, and nucleation of the crystal growth. The larger the freezing rate, more homogeneously distributed rounder and smaller ice crystals are formed. And if magnetic field assisted freezing generation of uh, generation of generation of the magnetic field methods. This you can see is the coil and magnetic field line. It's an electric current flowing in the wire creates a magnetic field around the wire according to the Ampere's law. As to generate the magnetic field in an electromagnet, a coil of the wire is would around the magnetic core with many turns. When the electric current is passed through the wire, the magnetic field of or the turn of the wire passed and penetrate the iron coil, causing the domains to turn, and the tiny magnetic field of the core are added to the magnetic field of wire, thus creating a large magnetic field. The, the intensity of the magnetic field generated is influenced by the number of turns in the winding and the current flowing through the wire I. The change the change the change brought by the magnetic field depend on the strength of the magnetic field, exposure time, and the temperature. The advantage of the electromagnetic of the permanent magnet is that the intensity of the magnetic field could be easily controlled by varying the amount of electric current in the coil winding, but the same time electromagnet require continuous supply of the power to be functional. Is this sheet the intensity of the magnetic field generated? B means magnetic flux density, Tesla or Gauss, and the mu zero is permeability of the free space. N is number of loops. L is number of turns per unit length. I is current flowing through the wire. Principle and working of the magnetic field during the freezing process. Magnetic field acts on the water molecule by the electronic and the nuclear spin of the atoms in the direction of the magnetic field. The cold air to transmit easily to the inner portion of the object and enhance the cooling rate and bring free water in the super cold state. And the spinning nuclei will also show rotational motion around the direction of the field, which will enhance the thermal vibration of the hydrogen nuclei, supercooling, and heat transfer throughout the product. This is benefit of the magnetic field assist freezing. A low cost low cost include as the in the reduction of the freezing time and reduction in temperature gradient and higher degree of the shift cooling, uniform and homogeneous ice crystal formation. No under no undesirable mass transfer, no development of the crack and damage to cellular structure of the food, less throwing loss, retain flavor and freshness in turn of the quality and appearance of others. And we in the lab we use the two-way and magnetic field assist freezing. First is using magnetic field generator with diffuser, and second is using commercial available refrigerant model. This first one is we set magnetic field generator in the deep freezer and put in the food item in the coil and freezing. And second commercial model is ABA Corporation's cell arrival system is cast freezer and Proton Corporation's proton freezer. This is the result of the already work done. You see the this fish meat. The left side is proton freezer using freezer, and the right side is commercial freezer, conventional freezer. Is we look more 드립이 적게 발생되는 걸 확인할 수 있습니다. And the others, and this is the red one, is colored water is we freeze the 제가 준비 부족으로 이 부분만 좀 한국어로 하겠습니다. 요 그림에 나온 것은 이제 캐스 시스템을 이용해서 얼린 것인데, 요 같은 경우는 이제 얼리는 과정에서 조금 더 이제 골고루 얼릴 수 있고, 그리고 얼린 푸드 아이템의 변화가 적은 걸 관찰할 수 있습니다. 요것도 마찬가지로 이제 프로톤 프리저를 이용해서 얼린 건데, 이제 왼쪽에 비해 오른쪽이 드립의 발생률이 현저히 낮은 것을 볼 수 있습니다. And this one is a CAS, and using CAS is more 보통의 통상적인 냉동을 사용했을 때보다 CAS를 이용한 냉동이 더 손상이 적은 것을 확인할 수 있습니다. And this conclusion of the paper is magnetic freezing is capable in the enhancing the degree of the supercooling, but at the same time there's a need to monitor various factors and conditions which influence the beneficial result of the applying the magnetic field while freezing. Matter of current that once if the applied magnetic field is removed, whether the product is still retaining the magnetic effect of the steel, it is required to apply the magnetic field during the frozen storage and subsequent thawing. This is recommended social paper. If you read this paper, this paper help you provide more 물리학적인 해설을 여러분께 줄 수 있을 것입니다. This is my reference, and thank you for this.